That concrete at the gas station isn't there for your car. It's there to survive the fuel. Roughly 1,500 litres of gasoline drip onto that same spot every decade. And if that surface were asphalt, it wouldn't last. After this, you'll notice where the concrete starts every time you fill up. Because behind a line you've crossed hundreds of times without ever wondering why, there's a hidden engineering decision most drivers never notice. Not strength. Why would a place built for cars avoid the same material used to build the road? That concrete around the gas pumps isn't there just because it's stronger. Strength plays a role, but it's not the only reason, and maybe not even the main one. Asphalt has a petroleum-based binder called bitumen, and the gasoline and diesel that drip around those pumps every time someone fills up can gradually weaken and soften that binder. Concrete is different. It's mineral-based. Water, sand, gravel, and cement. It doesn't break down the same way when fuel hits it. That makes it a far better fit where fuel is being handled. So the road can be asphalt, but the spot where your car takes on fuel has a problem with the very product being sold on top of it. And that problem is more interesting than you'd expect. Same crude oil. Think of it like heating a pot. The lightest things rise first. Gasoline, diesel, kerosene. The heaviest part stays at the bottom. And that's bitumen, the glue holding asphalt together. So the fuel you pump and the binder holding the road together come from the same barrel of crude oil. That's why spilled gasoline can be especially aggressive toward asphalt. The aggregate starts to separate and the whole structure breaks down. That process doesn't reverse. On a regular road, a spill doesn't last long. A car rolls through, wind carries it off, rain takes care of the rest. But at a gas station pump area, you're looking at the same surface getting hit every single day. So how much fuel actually spills? 1,500 litres. A few drops at a time, maybe a few milliliters when the nozzle is pulled out. Seems insignificant on its own, but researchers at Johns Hopkins University tried to measure them. Their estimate? At a typical American gas station, roughly 1,500 litres accumulate over a decade, about 400 gallons. If that surface were asphalt, every drop would be weakening the binder a little more. Over time, it softens, cracks spread, and water starts to pool. Fuel works its way through those cracks and into the ground. The surface fails, and so does the environmental barrier underneath it. But is this just a smart choice station owners make on their own? Illegal. In many places, it's not a choice at all. From California to Washington, state and local codes require the pump area to be paved with Portland cement concrete. Some say it explicitly. Asphalt shall not be used. It doesn't stop at the surface. The concrete, the slope underneath it, the drainage, the barriers around the dispensers, they're all part of one containment system built to keep fuel off the ground. Not a preference, a legal requirement. The line. But does that mean the entire gas station is concrete? No. Next time you pull into one, pay attention. The entrance lane? Probably asphalt. The parking area? Same thing. Because there's no routine fuel contact in those zones. The concrete starts specifically where the pumps are, the surface that meets fuel every single day. And now you know why it's there. You've probably driven over it hundreds of times. You never asked why. Because good engineering usually works that way. You never notice it. That concrete surface is more than a change in material. It's a quiet trace of engineers, regulations, and decades of experience, making sure the ground beneath the fuel doesn't fail because of the fuel itself. An ordinary surface, a question nobody asks, and behind it, a system designed to work without being noticed. We pull back the curtain on the invisible systems behind the things you see, touch, and use every single day. We keep asking why something works this way, long after most people have stopped wondering. If that way of looking at the world makes sense to you, like the video and subscribe to the channel.